Good afternoon.
Good afternoon. Good afternoon, Justin. Who else? All right. And hello, Yabo. Oh, hello. Oh, good afternoon, Kimberly. I was good. Thank you. You know what happened? And good afternoon, Sharon. And good afternoon, Jenna. And good afternoon, Wenyi. And good afternoon, Rachel. And it was good. Thank you. One thing, it is spring, everybody, which I have to say, good afternoon, Ali Nelly. Good afternoon, Rachel, if I didn't say.
Good afternoon, Professor.
Good afternoon. Thank you. Good afternoon, Marissa. Thank you. And it is spring by every definition, which is great. Good afternoon, Sarah. Like I'm it's spring. Oh, someone else. Sorry. And I know I maybe kind of ruined your springs. Well, we'll get to that, but it will be spring when this exam is over anyway. And okay. Good afternoon, Sarah. Okay, I think that's. And we will get this. So it's not, oh, and hello. Yes, oh, hello, Andre. Oh, and there's more. Sorry, wait. I just lost. Okay, sorry. Yes, okay. So just to get, yeah, so the usual business. I mean, I know, so we're in the middle of an exam right now. That's a bit intrusive in everybody's life, but it's not a coincidence that we have class today. Like it's like a new weird thing in my head that it's sort of good that we're meeting in the middle of an exam. And we will talk about that. And let me say, it even takes something to be in class in the middle of an exam. I think even if you think you're here to get help with it, which might happen, still showing up can be stressful. But anyway, I want to say though that, like, putting aside the exam for a second, I think that you guys and I are like caught up with each other pretty much. Like certainly anything that's been handed in to me, I believe, of any homework or any game turn or anything, unless you handed in within the last hour, I think hopefully you've gotten it back. And if you have turned in anything at all that you haven't got, and you turned it in before yesterday and you haven't got it back, let's look into it, because that's not because something's wrong. But why I'm saying this is also I did a little bit of cleaning during the weekend, cleaning up of the Google Classroom and stuff. And so it's totally conceivable that you might have gotten a couple of assignment, like game turn assignments that might have been due last Monday or something. And this did freak out a couple of people. I did not mean to freak anybody, and I don't remember if they were in this section or not, but like if you got ever, if you, other than an exam, if you ever get an assignment from me that seems to be due in the past, please consider that a bookkeeping thing, like especially any assignment that says game, a turn on it, that is all about you recording your class participation voluntarily for me. And I know I've said this before, like some of you are very bored by this, but I need this to be clear to everybody. Like every single time that you've been in class, whether it was a long time ago or just today, if you happen to have memory or record at all of any participation you did, include saying, hello, professor, like it's totally encouraged that you submit that for that appropriate day, whether that day was 3 weeks ago or this Wednesday, right? So I'm just trying to keep it organized so that there's a specific portal for every single day that's ever occurred. And thereby at any moment, if something occurs to you, you can use that portal. You'll never be considered late. What I'm really trying to say to everybody is all those game turn things, they'll never be considered late. They just have due dates on them so that you know where they correspond. But it's never too late to do them. And sometimes I'm just late with putting them up. So please, and really, I hope you guys are seeing, like, even if you say hello to me, and especially if you have like chat record or a screenshot, like that, you don't have to apologize for just saying hello. It means something, and I'm trying to reward you for it. But please understand that just for organization's sake, then they're all dated. So if you ever get an assignment that was due last week, it doesn't mean you're late with anything. It means I'm late with something, and I won't penalize you for it. Okay, sorry. Questions? Sarah, go. I'm sorry, Sarah.
Okay, so for the games that were like for the past week, if I don't have screenshots because I didn't think we'd have games for that day, do I still say what I said, or?
Oh, very good question. Very, 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 very fair question. Oh, and then Yabo, sorry, is somebody in the waiting room? Wait a minute, is someone? Oh, if not, then I'll get Yabo next question. But no, very good question for everybody. And again, all this is worth spending time on, right? Because this is your grades, right? And so The answer is yes to Sarah's question. Let me restate it, but let me say yeah. I mean, yes, you still can, yes. So what Sarah's in effect asking is, say there's some day where you believe in your mind you did say something, even if it's a hello, but you don't necessarily have the record. It's okay. The purpose of this thing is not to force you guys to prove things for 1,000 reasons. I'm going to believe you. Okay. It's not that I'm searching and demanding proof. What I'm really saying is that I think for all of us, especially once we get in the habit of taking screenshots or this or that, having the documentation just makes it easier for all of it. Like it just might make it easier for you to remember which days you did or blah, blah, or it makes it easier on your conscience so you don't think you're trying to pull one over me. But the documentation and everything is there too. Look, I have a pretty good memory for things. The truth is, okay, like I'm smart in some ways, and the truth is usually, especially when you guys say anything interesting, I'm actually asking you to remind me, because the minute you remind me, I'm gonna be like, oh yeah, I know that. I know who Sarah is. I know she said hello. Does she say hello every single time? Maybe not, but I don't think Sarah is like every single day demanding 50 points for saying she said hello and every single day not having evidence for that, right? Like it's all about patterns for all of us. I know I'm yelling, but I'm saying I trust you guys. I don't, you guys, frankly, most of you have, it's annoying enough to keep up with these things, even if you do remember in your conscience that you said hello. Like Sarah is saying, like, she didn't keep a record, but she remembered she said hello. But it's still hard enough to keep track. I think very few of you would go to the huge trouble of making up these big ornate lies and submitting. If you every day submit and said, I say hello, and you keep doing that and you never have any evidence, of course I know that you're lying, not you, Sarah, but somebody. Like, don't worry about proving that you're telling the truth to me. I know that you are only going to lie to a certain point before it gets silly, and you'll know the truth and blah. So the evidence is just to make it look more like an assignment, just so that there's something concrete in the box that I can mark on and stuff. But no, you guys, I trust you guys. It's self-reflection. The reason I'm putting you through the exercise is that you have a moment of self-reflection. How much did I participate that day? Maybe I could do better tomorrow. Like you're confessing to me. It's hard enough to tell the truth. Anyway, I'm overstating this, but please, all of you, if you're in your conscience, if you you said hello 2 weeks ago and you just never submitted it, just submit it. I trust you. I want this. It's just a way of us all. And now if you see all the class notes are more organized, all that, it's just a way of us all treating this whole class as one big set of daily experiences that we're all a little bit responsible to and a little bit tuned into. It's like that, so I'm overstating again, but I have been noticing, like, honestly, the submissions are dropping off enough, maybe partly because I fell behind in putting them out there for you, but they're dropping off just enough that literally if we never had an exam at all, I could give a distribution of grades to this whole class right now. Like this is not a threat, but this is what's so crazy about a system like this. Literally right now, we could stop and I could give grades to everybody just if those things counted not as extra credit, but as percentage things. You all could fall into a grading distribution now where like some of you would get A pluses and some of you would get S. It's just based on who's handing those things in or not. Now, I don't want it to be that way. I want some of you to never have to turn in one of those things at all, but you rock on exams so much that you earn your A fair and square. Like, I want there to be different ways for people to earn A's, but I'm telling you all right now, it's apparently a pain in the butt enough to do those things that some of you are guaranteeing your own A just by doing them every single day. And it's trouble enough to do them that I just don't see people taking that much trouble to lie that elaborately. If they did, I would know they were lying. I know who's in this class and who's not. Okay, I'm talking way too much, but please do them is what I'm saying. Okay, Yabo, I'm so sorry. Yabo has a question. Go.
So do we have to actually prove the particle inside of the shell, the net force is 0?
Oh, okay.
Do I have to write it down?
Yeah, that's a really good question too. Okay, let me shift. I want to answer that in depth to everybody. I want to make sure everybody, I might have to repeat that question a second. Let me also look. I'm also going to chat one second. Oh yeah, okay, sorry, wait. I definitely want to answer Yabo's question in a big way. It's possibly one of the bigger things of today. So I'm not going to, so before I do to everybody, because Yabo's actually now asking something about problem 3 of the exam, which definitely is worth talking about today, is before I change the subject though, I'm just looking at the chat just to clarify everything like that we were just talking about homeworks and stuff. Number one, yes, partly what I think is confusing, I just forgot to post those things last week. So then I posted them late and I think that freaked people out. But the reason I did that is, again, just so that you have an opportunity for every day. And second of all, in terms of not remembering, Well, I understand if you don't remember what you said on past days. So I'm not saying, I get that. So, but again, even if you let like 4 go by now and everybody kind of let 4 go by, they're not being held against you. They're all just optional points. But it's just, again, it's just a reminder as a habit, like on any given day, try to remember that day and just get it in fast because then you get the points. But again, look, the last way to put it too is, if you know that 2 weeks ago there was a discussion and you definitely said something like when we were discussing the exam, like, and someone already did put in a bunch of stuff about this, but when we were discussing the practice exam right at first, people definitely got into it and found errors and stuff like that. If you know that you participated in that discussion, but you don't remember if it was like last Tuesday or the Monday before, well, number one, what you could like go through the class notes and stuff, and maybe that's part of this too, is to start seeing the class as a whole. But number two, who cares? It doesn't matter. If you just know that you participated in that discussion about the exam and you remember what you said, so you put in for 1 day, you don't put in for 3 days, put in for 1 day. I'll see it. I don't remember which day that was either, but I'll remember as soon as you remind me that you talked about the pre-midterm. I'll be like, oh yeah, that was cool. Thank you, 50 points. But if I've never heard of you ever, and you're sitting there saying like, and I talked about the acceleration and Hooke's law, like you might get away with that once or twice, but after a while, let's not be ridiculous. I mean, I do have, like I know. So don't kill yourself what you can't remember about. Just, it's an intuitive, impressionistic thing. There's tons more classes where you could start doing it now. And if you knew you said hello, then you said hello, and I believe you. Like it could be that deep that you said hello. But all right. Right. So it doesn't matter if you don't, right. It doesn't, right. So what I'm trying to say is, yes, if you remember that you said something, but you don't remember the exact date, you can totally estimate the date. Yes. Like you can pick which date you think it applies to and throw it in. And I'll know you're being reasonable too, because what you won't do is put it in for 3 days in a row. You'll just pick one of, you don't know if it was this day or that day. So you pick one of them and submit it. Absolutely. Guys, the other thing about this, why I like it and why I am spending time on it is and I think those of you who have done it have noticed just the 2 minutes that you take to reflect on where you were in the class that day, and just like it forces you to remember what the class was, and you send that to me. Then for 2 minutes, I look at your handwriting, or I look at your font, or I look at your name. And for 2 minutes, it forces me to remember you again as a member of the class. And we're both just like taking 2 minutes to reconnect and be like, yeah, we're in the class together. Yep, we get what's going on. Like it's very kind of satisfying. But that's why I think you deserve 50 points to do it. But don't overthink it. It's like a checking in with, your class diary from the moment. And I see it and I'm checking back and we're like, yep, your grade is still intact because we're together in the ship. Like, right. So don't overthink it, but feel if you have an impulse that you were part of class that day, just convey that impulse to me. Okay. Now, Yabo's question. I don't mean to rush on, but all right. Yeah, that is kind of, I mean, I appreciate the way, yeah, I am kind of trying to say something like that. Like we're all cool. Like we're all cool until we're like totally not. Yes. But now Yabo's question, which is definitely cool. Okay. The third problem on the midterm. First of all, the third problem is where I'm delighted to spend the most of my time talking today, because I would think that all of us would have the most questions about it. It is by far the newest, hardest thing I'm asking you suddenly. It's kind of like you practiced all your skills on the first 2 problems. We went at our pace. And now I'm asking to put a lot together, like, and really show your physics skill on the third. So, okay, there are questions. First question, Yabo's question, I have to say the answer is yes. He is asking, I do believe the answer is yes, which is probably not maybe what you want to hear, but Yabo is asking on the third problem, when we say that at some point in our solution, and part A specifically is what he's talking about, part A of the third problem in the when I'm asking you to derive the net gravitational force, it is absolutely true that in the solution I'm looking for, in the correct answer that I'm looking for, there's many stages. It is like a proof or derivation. Somewhere in there, I am absolutely expecting people to tell me that the total gravitational force exerted by a shell around a particle, like an empty shell, you do have to say that that is 0. That is part of the argument you're making. Like, and I'm still not answering the question yet, but so far, in other words, premise of Yabo's question is correct, that I'm expecting that somewhere in the argument, you're going to say that if you were just in a shell, that everywhere in the shell adds up to make 0. And then you're going to use that argument later on to come to a deeper conclusion about what happens in the solid sphere. Okay. Now, Yabo's question is, when you say that the entire shell contributes 0 net to a particle. Do you have to explain that, or can you just say it? This is an extremely fair question. This is an extremely fair and relevant question, because especially this is all new. I could see it either way, but I'm actually saying, I want you to explain it. And I'll tell you the explanation right now again. I'll tell everybody. But
Wait, hold on. Your explanation is not legit. Like you have told us before. You use 4 pi r squared. That's the area of a sphere, but what we're dealing with is area of a cone of a sphere, which I found online has a pretty yeah, there is solution for the mathematical solution, but the mathematical tools, we don't have it at all. You see where I'm going?
Oh, I see where you're going. Oh, I think it's very interesting. I do see where you're going. Yeah, I think it's a little bit of a strong statement to say we don't have the tools at all. But no, I do see where you're going. All right, let's back up. Very fair question.
I just DM you the like legitimate solution, and you can take a look at it and tell us if we know those kind of stuff. I don't think we haven't learned those stuff at all.
That stuff you have not. No, I agree. And that there's aspects of that we're not going to, and I agree. That's very interesting. You're saying all this. Let me back up. Number one, what I do agree, I do absolutely agree, and this kind of can shift the whole discussion. I do agree that the argument I'm saying in class that I want you to say is an approximation. That is definitely true, that we are only approximately showing why it's approximately true. We are not showing why it's exactly true. That is true. So let me say again to everybody, and it's true that the specific argument that Yabo is looking at or finding online, one way to specifically exactly prove it, we don't have those tools. That is true. And I'm not expecting those tools or wanting those tools. That is true. So it's definitely true that all I'm asking right now is an approximation. That is true. And I even want to go a step further with what Yabo is implying or saying. He's saying there's something a little bit unfinished or unsatisfying or not wholly good about this. I even agree with that, because we are going to go further with this in the course. We do have to see something more exact about this. It kind of is why we're setting a first stage right now. So all of his concerns are totally right. But and one correction I'll even make, it's true that what I'm asking for here is an approximation, not a strict exact. That is true. Hold on. Wait, okay, there's an important question also in the chat, but I'll look at it. I'll look at it again in a second. But so this is a very fair question. Let me try to be as clear as I can on the board what I'm saying. Now, and I want to emphasize this again, because I'm not playing it like it is an exam. Grades are important, and feeling like, and I'm asking everybody to feel like what they're doing is honest when they hand in their graded material. So again, I don't want to beat a dead horse, but I want to, this is it's a tricky exam, and it's a tricky question Yabo's asking. It is, again, let me just emphasize, more than fair question, more than fair. So let me be as clear as possible. It is true. We can even interpret it as politely as possible. If we even want to interpret what he's saying as, if we want to regard it as a flaw or a limitation or an imperfection or a weakness, let's even say, in the whole question at this stage, we can even say, like, I'm willing to say that for the sake so that there's no deception or confusion when we're taking this exam. Yabo is saying, and I agree, that with the tools we have so far, I can only approximately argue. I can try to convince myself of the seeming reasonability of the effect of a mass shell around a particle. And I am asking everybody to know this argument. And you can even put, let me, like the argument, and I'm going to repeat it again here, like the thing that I said last Wednesday. I am looking for it on the exam, to be fair and clear, like for grades and stuff. I don't just want people to say that a shell produces zero gravitational effect, especially because, as Yabo is pointing out, it's a controversial thing to say. Like, even when we sort of argue for why it should be reasonable, it's still a surprising result that has arguments against it. So if we're going to use it in our exam, I do want it to be argued. Now, what Yabo is pointing out is that the argument is not perfect. So feel free, everybody and anybody, whether this is Yabo or anybody else, when you put down this argument in the test, you can definitely say, I don't like this argument, or I think this argument is limited or weak or imperfect, or I'm not satisfied. Like, and I'm not being joking. You really can do this. And especially if it makes you feel like the whole thing is cleaner to do. It's just like putting a squiggly equal sign rather than a strict, like you're saying, this is only approximately true and I'm not going to, so that's fine and maybe best. So we can take this as Yabo's almost like a correction on the test, that we should be clear about that. But now what is it that I want people to be clear about? The thing that he's raising is this, the short version is this. The key thing that, this is, yes, what I'm talking about right now, sorry, what I'm talking about is totally about number 3. And I see that there's a very helpful and important question in the direct chat, but I'm not going to get to it just yet. I'm going to try to do this for, but yeah, but this is about number 3 that we're talking. And here's the thing, and again, I'm trying to be very clear. Like, I want, we could have a whole discussion of whether it's a perfect exam or not, and stuff like that, right? But just right now, we're just like doing it so we can get a grade. So again, to back up, like something that was implied by Yabo's question is very true, which is that I'm expecting you guys to explain a certain step. I'm expecting all steps to be explained. That's really the thing of the exam, is to explain all steps. And what Yabo has found is one piece of one part of the exam where what I'm asking you to explain, like, cannot, the more you think about the explanation, the more you realize it's not a perfect explanation. And the thing is, I even made jokes about that when I was giving it. I made little like embarrassed jokes because it's not a perfect explanation, but it's a classic, historic, and important and helpful explanation that I want people to know. And the explanation I'm talking about, the imperfect explanation I'm talking about is this, to explain and by the way, when in doubt, whenever we say explain, make a diagram. When in doubt, if you think there needs to be something explained, especially if you're thinking he wants me to explain something, but it seems so obvious to me, either seems obviously right, so I don't even know what he wants me to explain, or like in this case, it seems obviously flawed, so I don't know what he wants me to explain. Either way, when in doubt, go to a diagram. Diagrams explain things when they're labeled properly. So what I'm talking about here is that if this is a spherical shell, a spherical shell of mass, right? Like this is all mass. It could even have some thickness. Like It doesn't have to be, although it's easier if it is, but it doesn't have to be infinitesimally thin or anything like that. It has some thickness as long as that thickness is uniform. So if this whole thing is a shell of constant radius capital R, what we are arguing in problem 3, in part of problem 3, we're saying that if a little particle m2 is at some variable displacement from the center, lowercase r, right? Like again, this whole thing is capital M1, and we are some little test particle m2 at some variable arbitrary displacement, lowercase r, from the center of this, if we're in the vacuum of this space, right? I'm saying that the net gravitational effect on that little piece, I'm saying that the net gravitational effect on that little piece from everything added up all around the shell is 0. Okay, I'm saying that, and I'm saying you have to say that somewhere in number 3. But what I'm saying is there's an argument for that, for at least why it's plausible or somewhat approximately believable. And the argument has to do with that picture that I gave you. The argument is that if you take that little mass chunk M2 and look at it, and you look at this section, now this is the thing where Yabo is saying this is technically a cone. I'm looking at, I absolutely agree with him. But that surface of the cone is nonetheless a surface of a sphere. Like the two are not mutually contradictory statements. This surface right here is a region, a sector. It's a portion of a larger sphere. And it's a certain amount of mass that's pulling that particle this way. And were it for nothing, if there was nothing else going on, that particle would just pull that mass that way. However, there's another chunk over here that's pulling the mass the other way, the direct opposite direction. Now, do I know how the magnitudes of the two chunks compare, or the two forces for the two chunks? No, I don't offhand. This is where the argument comes in. What I argue is, oh, like this thing is this thing down here is a much bigger chunk of mass than the smaller one is. The question is how much bigger? And my argument is that it's as bigger as the volume is bigger, because this is a uniformly dense object. In other words, I'm arguing that any two chunks I pick, they're not going to be the same masses, but they're going to compare in masses in direct proportion to the way they compare in volumes, because we've specified uniformly dense spherical shell. And that part's that's true. That's exactly true. Then I say, well, if they're going to be in proportion to masses in the same way that they're in proportion to volumes, then I say, well, the volume is 3 dimensions, like length, width, thickness, or however you want to call it, and the thickness, or length, width, height, whatever you want to call it. But with these two of these mass chunks, their thickness is the same. They're both cut out of the same uniformly dense shell. So they only could be different if they're different in size. It's only in terms of their relative surface areas that they would differ, like not their thickness, but the other 2 dimensions of their volume. So then I say on the next page, okay, then the mass of one is in proportion to its surface area as the mass of the other is to its surface area. Okay. And this is 1245. Okay. And here's the part. Okay. So far, I say this is all true. I don't think there's anything wrong with it. Now here, I say, okay, the surface area of, so now I say that I say the surface area of a sphere is 4 pi r squared. And it is, like the surface area of a sphere is 4 pi r squared. This is where Yabo correctly says, well, wait a minute, you're using the surface area of a sphere. I kind of see that, but what I really see is 2 cones. Shouldn't you really use the surface area of 2 cones? And I'm going to say, yes, he's right. Here's where so right here, I'll go like this. Like it should be as clear as I can to everybody. Okay. The argument that I now make, if you look back at the diagram, is that what I'm trying to say is like the bigger either one, the I'm saying which either chunk, if you view these as chunks, if you view each one of these surface areas as the surface area cut out from some larger surface area of a sphere, right? Then the bigger the radius of that sphere is, here's the r right there, or, sorry, the lowercase r. The bigger that r is squared, the bigger the surface area of that chunk is. And I'm saying it's that ratio. Like the bigger one r is, the bigger its surface area is, the bigger the other r. So if you double the r, you quadruple the surface area, I'm saying, right? Yabo is saying not exactly. And he's right. It's not exactly true. Like it is true that each of it's true enough to make a good point, and that's why I want everybody to make the point. But it's also true enough for Yabo to say it's not exactly true. What do I mean? I mean, and I'm not trying to confuse anybody, but I'm saying what is true is that if you double the radius of a certain sphere, you'll quadruple the surface area of that sphere, and that's the argument I'm making here. But really, strictly speaking, what Yabo is pointing out is that each one of these chunks is cut from a different sphere. Like this chunk has one R and this chunk has a different R. So when I compare, so they're not cut out of the same sphere in effect. Like they're not cut out. This one's really cut out of a sphere whose radius is that, and this one's cut out of it. And that's where he's right, that I can only approximately now say this. But I can approximately say it, but I can't exactly say it. So I'm going to say approximately with this approximate equal sign. And then I'm going to say, and the truth is, even if they are cut out of cones, it's still true that the ratio goes as with the R squared. It just doesn't go perfectly the way I would like it to for this argument. So these go like this. And then I say, okay, thus, so what I'm of each of these. So what I'm saying is that if this mass is twice as far, if this red mass over here is twice as far away from the particle as the other mass, then if it's twice as far away, then it's 4 times as massive approximately. But according to the force of gravity, if you're twice as far away, you exert 1/4 as much gravity, right? Like there's an R squared, in other words, but for each one of these chunks, the farther away you are, the less gravity pulls on you as a function of the inverse of the square of your distance, like this R squared in the denominator. So what I'm arguing is that the two R squareds approximately cancel each other out and leave you, and okay, now I'm trying to write this sort of quickly in my, don't write my exact words in the exam. I mean, of course, but I'm trying to, so I'm saying what we're trying to argue here is for any chunk that's pulling you in a shell, there's another chunk on the opposite side. And if you compare those two chunks, the extent to which one chunk is farther away than the other will lead to two things. One, if one chunk is twice as far away as the other, then it will be on the one hand 4 times as massive. So it would seem to pull 4 times as hard. Yet it's 2 times as far away. So it's 1/4 the pull based on gravity itself. So the two effects mitigate each other and you're left with approximately nothing. Now that is an approximate argument. There are better arguments to be made, some that deal with like the surface area of a cone, which we won't get into in this class, but others will be made in this class and we will see them after this exam. So this won't get left unaddressed, but it is stage 1 of an argument. Let me just one more pause and then hopefully this sort of helps. But so I am saying on the test, you do have to argue, like in your own words, try to argue, and it can be, for some of you be more diagrammy and less Englishy. It might be more equationsy and less diagram, everybody has different styles, but you want to argue somewhere in this test, okay, if you're in a shell, all the mass will cancel out to be 0. And then you're also saying, if you're outside the shell, all the mass reinforces so that the whole thing acts as one big point located at its center. And then you put those two things together. You say, if you're in the middle of a solid sphere, it is as though you are receiving all the effects of a planet beneath your feet, plus all the effects of a shell around your head. Like that is the argument. And I'm telling you the answer because I think this is hard enough, right? I mean, the fact that, I would spend this long on this question, like I'm telling you guys what the answers are on this exam, but what I want you to show me is that you actually understand them. So again, it's a very reasonable question. What exactly am I looking for? But I'm looking for this argument here. I'm looking for, I could show you that reasonably why the mass of a whole shell will cancel out to 0, why the mass of a whole planet underneath my feet will all act as though it's located at the center. So if I'm in the middle of a solid ball, somewhere between 0 and the edge of a solid ball, it's as though there's mass above my head, all canceling to 0, plus all this mass below my feet, all just acting as the mass below my feet. So then I solve for that mass and I plug into GMM over R squared and I get GMM R over capital R cubed. Like, let me say this slowly now. And again, I have to stop for a second. I have to look in the chat and I have to give you a link that will help also. But again, some of you, I might be losing some people in the nuances of the abstractions, but in problem 3, part A, you're ultimately trying to show something a little bit unusual or new. You're trying to show what the force of gravity does inside a solid sphere. You're beginning with the premise that outside the solid sphere, it's GMM over R squared. Let's say that is a given, like that force that's coming from Newton. But then you're doing this twist and turn argument to show approximately that once you're inside the solid sphere, it no longer is GMM over lowercase r squared, it's GMM, and I'm going to get Yabo again in 1 second, and then I'm going to move, wait, let me just check the time. I will get you again in 1 second. Yeah, well, I'll just finish this thought, and then I do want to, blah, blah, but I'll get Yabo again in 1 second. But you're trying to show that even when we assume GMM over lowercase r squared for like 2 particles, that for this complicated construction of being inside a solid sphere, you get GMM lowercase r over capital R cubed. In other words, the lowercase r flips up to the numerator and the exponent disappears. Like all of this is to show that that happens. And then if the r is in the numerator, all of a sudden we have a Hooke's law spring due to gravity. Like that's what comes into part B of problem 3. But all of part A is kind of a long, complicated thing to show another case where a force is directly proportional to displacement. And it is an approximate argument. We'll get an even better argument after this exam. Now, let me just see. Hold on a second. Well, yeah, sure. Sure. You could call it eyeball. Yes. But is it now? I do want to, there's a couple of things I want to do before I forget, but Yabo, was it, you can ask the other question, or I don't know if that's what you were going to, do you want to follow up?
No, I got another
Okay.
question. Like, I get your part. Like, we're not gonna prove it mathematically or arithmetically. We're just gonna approximately. I get that. But for the very last question, like, what exactly are you asking? Are you asking for like same angular frequency, or like what does it even mean for the last question?
Part C, you mean? Part C?
Yes.
Oh, okay, great. Yeah. All right, I'll tell everybody this now too. Yes. And that's the most surprising. It's much easier than it looks, believe me, but I'll tell everybody. So now part C of problem 3, if everybody's still with me, and I know there's still something in the chat I got to get back to, and I'm trying to watch the clock and everything, but in part 3, it says, asks you to go back and look at what you did in problem 2, and it's asking you where, okay, in problem 2, if you all go back and look at problem 2 in the exam, it says at the beginning you got this pendulum, but the pendulum, it says it's like deep underground. It tells you that. In other words, it's asking you, don't assume 9.8 for anything you're doing in problem 2. And that's all it means. Like, just don't assume anything about 9.8. And you don't have to, and there's no reason to. But so you just do all of problem 2 normal, and you get the angular frequency in problem 2, and you get period and stuff. But between you and me, by you, I mean all of you in the class, we know from lab that if you just like analyze a regular pendulum, I mean, if you, well, and you know from the differential equation and well, you know what you do in problem 2. What I'm trying to say is you all know a relationship. Actually, I'm not giving anything away. Let me be clear. Hold on a second. I'm saying, hold on. Okay, now I would be very careful here too. This is like where I am trying to be cool, but not too cool or whatever. I'm saying nudge, nudge, wink, wink. We all know in this class and me, we all know, I think we know, or I hope we know from lab that when you're dealing with a pendulum, like T, the period is 2 pi times square root of L over G. Now, in truth, really, you're even trying to show me that you know that in some part, in the last part of problem 2, like just to be as clear again as possible. I do kind of expect that this is familiar to you now from lab and stuff, but you're actually even trying to wait, yes. Yes. So Yabo, yes, to what you just said. I'm going to keep saying this, but yes, totally yes. Good. But now to everybody too. And again, I know there's other things in the chat I have to get back to, but you all know this, but in effect, I'm asking you to prove this in the last part of problem 2. I'm asking you to show me why we even think there's a differential equation that has an angular frequency, like a constant of proportionality. Like you're trying to show me in problem 2, how everything that you see about masses and springs in problem 1 also applies to small angle pendulums. Okay, that's problem 2. Now, I'm not trying to distract anybody or confuse anybody or dodge a question. But in problem 2, what's lurking around problem 2 is this statement right here that I just wrote. Or you could put it this way, if you like this, but this statement, either one, right? But you know that you all know from doing the differential equation and stuff, there's a relationship between whether the angular frequency or the period of the pendulum and what the acceleration due to gravity is. Now, normally that acceleration due to gravity, like that you in the lab, is 9.8. In our regular real lab, it's 9.8. But I'm saying in problem 2, just do everything in problem 2 normal, but just imagine you weren't on the surface of the earth. Imagine you're deep within the earth, somewhere where gravity is weaker, where it's not 9.8. Like, and remember again, if you think about problem 3 now, like at the center of Earth, gravity would be 0, right? That's sort of what you're realizing in the middle of problem 3. And in fact, if you really take problem 3 seriously and get what you're doing in part A of problem 3, you're trying to figure out what happens to gravity throughout the inside of the earth. And I'm not giving anything away when I say, although I totally am, that if you're doing part A of problem 3 correctly, you're ultimately realizing that gravity gets stronger and stronger as we get out and out from the center of the earth. Like literally what you find. And again, if you're hearing what I'm saying and you're like, oh my God, he's totally giving away the answers, then good, then you get what's going on. That what you're finding out in part A of problem 3 is that gravity is linearly dependent on displacement from center, right? Like literally what you're finding out in part A of problem 3, if you're doing it correctly, and if you're just following, but if you're understanding it, what you're finding out is that at the center of the earth, gravity is 0. Like that 9.8 number, it's not 9.8, it's 0 at the center. If you were at the center, the dead center of the earth, you'd weigh nothing. And of course that makes sense because your weight is you being pulled toward the center. If you're at the center, where are you being pulled? Like you're down, there's no down to go. But now if you get a little bit out from the center, what we're finding in part A, if you follow all this argument that you're doing, or at least you even follow the last answer, you find that F equals blah, 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 times lowercase r in the numerator. Like as you get farther and farther out from the center, the force of gravity increases linearly as a function of r, literally meaning if you go halfway to the edge of the earth, your weight isn't going to be mass times 9.8, it's going to be mass times 4.9. Things will free fall at a rate of 4.9 if you go halfway from the center to the edge of the earth. Did we all know this before? No. I'm saying this is what we're finding out in part 3, that gravity is linearly dependent on distance as long as you're inside the earth. So I am totally giving something away, but if you're here today, this is your reward for being here and for asking these questions and for having looked at the exam already. I'm saying that you go about your business in problem 2 and you just answer all the questions in problem 2, but realize that you've got an angular frequency and therefore a period like floating around in your answers in problem 2. If you actually worked out and solved, I mean, I'm really giving something away if I say this now, but if you actually stopped and solved for G in the middle of problem 2, like as though it were a lab experiment and we were seeing if we could figure, you'd find that G doesn't equal 9.8. And if I didn't tell you otherwise, that would be a good way to know that you'd think your answers were wrong or something. I'm telling you to feel like, unless I made a mistake. I mean, I've checked the numbers many times. And if you're doing it right now, please don't tell anybody, but I'm saying in problem 2, if you look at your angular frequency and you look at your period, like with whatever numbers I gave you, you have enough information to solve for lowercase g. And if you do, you should find that you won't get 9.8 because I'm telling you, you're not on the surface of the earth. You're somewhere amidst the earth. And all your work in problem 3 is to get you to see, oh, wherever I am in the earth will determine how much G I feel and vice versa. Whatever G I feel is where I am in the earth. So the answer I'm looking for in part C of problem 3 that will really show that you've put this whole exam together and everything, it's not a trick question, but it's not like a huge, it seems like out of nowhere, but it's kind of a one line once you see it. In problem 3, what I'm asking for, something like I am 1/3 of the way out from the center of the earth, I'm 1/10, I'm 1/4, I'm 1/2. Like you can literally find out what fraction of R you are by looking at what fraction of G you get in problem 2. I think I've said a lot, but it's okay. That's what's going on in problem C. I'm sorry. Yeah, in part C of problem 3 is it's asking you to actually understand that you just got G as a function of R in part A. So relate that back to the G that evidently you seem to have in problem 2. I'm really going to shut up now. But I'm really going to pause too because there was something in the chat I never answered. Plus, I want to give you a link that you could follow to see a little bit more about this gravity thing if it helps. But hold on one second. Oh, yeah. Okay. Wait, this is a good. I want to pause for a second. Okay, bear with me, everybody. And you all of you too, feel free to like look through, take in what I've just said. And there could be other questions too as well. Oh, there's a thing. Okay. But I want to give you all a link too for 1 second. And then I want to answer a question that is good that's in the chat. But give me a second. Hold on. Sorry, I'm looking for. I will. Oh my God, if this, all right, one more thing, if this doesn't work. What? All right, I can't, I don't know why. Oh, here, okay, okay, I'm sorry, let me, I just want to give you. Okay. This. Uh, This is taking me way too long. But I. Okay, I'm putting this in the wrong place. Okay, I'm taking way too long for this. I'm going to fix this later. I just put a link in. I'm going to start talking again. I put a link that you shouldn't even waste your time on. Most of you, you shouldn't waste your time on, certainly now. And while you're trying to study, you shouldn't necessarily waste your time on. But I appreciate the link that Yabo gave me and the discussion, that topic he raised here. And there's a link that I just put in the chat for later. And I was just trying to put in your Google Classroom thing and put it in the wrong place. I'll fix it later. But it's a link of an argument for Newton's shell theorem that goes way too fast, and the music goes too fast. It got recorded badly, but I made it a long time ago. It goes way too fast, but it's my argument for this result that we're talking about here, often known as Newton's shell theorem. It's another way to see it. It goes way too fast. It won't necessarily help you study for this exam, but it will help maybe in my acknowledgement of the depth of this question and of the nuance of this. Like, there is a lot beneath the surface that's going on with this cancellation that we're talking about. And it's very historically important. So I do have one version of it that you can play if you want or study at any time. And that's the link that I just gave you all. But also, let me just say, because I do want to move on to this other question that's in the chat. I've just spent a considerable amount of time on this question, but there's a reason. I do think it's among the best possible questions that could have been brought up today in this sense. I mean, there's a lot of great questions, but like what Yabo raised is kind of, I would say, all the way at the edge of the highest level of concern about this exam. That is to say, like, if you're following anything I said about it at all, about this question, about problem 3, part A, and the nuance of that argument, that you're in very good shape, because it's definitely the hardest piece and the newest piece of the whole exam. It like, if I had my druthers, it is the kind of thing I'd be talking about today, because I'd like to be the most helpful with that newest piece. I'm sort of secretly fantasizing that the fact that that's the question that came up maybe means that you guys are kind of okay, at least on the first problem. And also, hopefully I tied this back to the second problem somewhat for you guys. So it was not, if there was only going to be 1 or 2 questions asked, that was not random. Please understand, like, that's kind of where I would have guided things today, kind of anyway. That's why I'm spending so much time on it. But now, if that makes sense to anybody. So again, if you're insecure at the level of what we were just talking about, that is the level to be insecure about. Like, that is the edge of challenge for this exam. But now, I got another question in the chat that was good also. And I'm not going to read the person's name because it was in the private, but I do want to read the question out because I think it does get at the heart of, like, so it says, the question says, given that the exam is basically the same format as the practice exam, is it okay to almost mimic the way you answered the questions? You, meaning me. Is it okay for you guys to almost mimic the way I answer the questions while also adjusting the format to your own style. The way I explain Yaverbaum, the way I explain to solve the questions is like obviously supposedly the right way, or at least well, the way I gave you credit for. So the person asking says, oh, I want to make sure it's okay to follow along with your way, Yaverbaum's way of solving the problem. But obviously a huge part of the exam is to be able to explain how you even got to conclusions, but I don't want to make it seem like I'm only copying your work and not doing my own. Like this, and it goes on, even though all the numbers are adjusted. This is a very fair question. Again, if you're concerned, if you're like, I think I know what's going on in this exam. Like, I think I get it at this point. Like, we've done it a number of times. Like, he went over the practice. Like, if you're thinking, I think I get this, but now how can I prove to him that I'm not, like, I get it, especially when I'm looking at the solutions. How can I prove to him that I'm not just like copying his solutions? That is a very, very fair question. Because I do want solutions from all of you that are as right as mine, so to speak, but I don't want you to just copy them. That's true. On the other hand, I'll tell you, if you're going to copy anything, I'd rather you copy me than some random thing on Chegg or something. So what do? Okay, very fair, because I think that's what this is a test of. This is a test of integrity, a test of how can you guys actually show yourself that you get this stuff, not show yourself that you made it up, because you didn't and neither did I, but how can you show that you get it? How can you, the way to show me is to show yourself. It really does work like that. I will know that you're not cheating if you know you're not cheating. It really does work like that. But here's better advice, like more concrete advice. First of all, if you're really in doubt, see what you can do without looking. Like, honestly, like if you really want to test yourself, try to give me a solution set that even if you've looked at mine a million times and now you're sure you're just reciting it from memory, I guarantee every one of you, if you write out your solutions for handing in, if actually while you're writing them, you weren't looking, even if then you go back and take my solutions and check everything, which you're welcome to do. But I guarantee you, if you're not literally looking while you write out, then no matter what you're going to write out, if you get it right, if you check again and you look and like, yeah, no, I think I've covered everything. Yeah. If you actually do it without looking, guarantee your personality and your own way of understanding, you'll be forced to rely on it because nobody could literally memorize all of this. You might try, and God bless you. You could try to memorize my solutions, but then if you sit down there and do them without looking, I know you're doing it your way and it's cool, but you're still allowed to look. But that's one test. But the other thing is, and I know this works because this is how I was put through college, and I was put this way through even philosophy exams, not even physics. Like, in other words, where the best way always to show that you're doing it my way, but your way, is just do everything I do, but with different examples, like different sub examples. Like, make up examples from what you're like, and just call them different things. Like in the part that I just did for everybody, the NAMB thing that I just did. Again, you might not totally agree with it. Like Yabo doesn't love it. And by the way, that's a surefire way to show that you understand something. Oh my God, the easiest way to show you understand something is give it a critique while you're doing it, which you're all welcome to do. You can write down stuff and be like, this is the deal. But by the way, I don't get this. Or like, I think this contradicts something else. Sure, if you have an opinion on it, it really shows you get it. That's number. And I'm not saying I love every ounce of every one of this physics, but the other thing is, every time I'm doing something in a diagram with like MA or MB, just change the names to protect it. It's like you change it to MD and ME. You think that's like a trivial thing, but even going through that act, if you change every one of my symbols or even my fonts, if you consistently change what I'm doing to your style or you change colors, it seems like a joke, but it's not. It's hard. It will show you. In other words, when you're trying to understand something, it often ends up accidentally being copying. But when you try to copy something, if you're going to get it right, it only works if you actually understand it. Like, so don't try too hard to prove to me that you didn't just copy my stuff. If you don't allow yourself, like, as long as every single thing you write down, even if it came from me, if you know in your heart that every single thing you're writing down actually makes sense to you to the point where you have an opinion, like you agree with it or not, then you know you're doing it right. And when in doubt, break down any step into further steps. Like, sometimes I divide both sides by, sometimes I cross multiply when I should have. Sometimes I do things in 2 steps, just break things down into fewer steps. But really, if your biggest concern is you think you get it, but you're not sure how to prove that it's different from mine, don't over worry about it. Like, even just if you've gone through the salute, I'm going to stop talking about this, but there's enough minor errors in those solutions that if you just looked at them blind and you never attended class and you just tried to blindly copy I know this for a fact. Anybody who has not been paying attention all today or last Wednesday, if they just literally, there's enough errors in my solutions that were found on the first day. If someone just had them and just tried to copy, it would be a mess. my thing is a mess. You have to, even just to cop it, you have to clean it up enough in your own mind to understand something. I'm going to stop talking about it. But believe me, I trust those of you who trust yourselves. You'll know it and I'll know it. And I'll also know it if it comes straight from Chegg. And that comes from people that aren't even paying attention right now and will use notation that we've never seen before in this class, et cetera. Okay. All right, let me just look in the chat. I'm sorry. Yeah. Like the more you can add your own little, I just saw this in the chat. Anytime, like really, again, for all of you, the more you actually understand something, just add commentary, diagrams, pictures, cartoons, anything you understand, just flag it and show that you've got something to say about it. And then the stuff, you know how to show it when you understand. I really do. Okay, Yabo, sorry, go.
There's a big typo. So for the second last question, in the body of the question, you're asking for the time in a moon, but like later on, you're saying,
Oh, it says
I
moon?
give you.
Oh, it says moon? That is a typo. I'm sorry. If it says moon, I'll change that right now. It
It
should
should be
be.
as Earth, right? Because you
Yeah.
give us the number of Earths.
Yes. Did I give you? Yes, you're absolutely right. Did I? And if I said moon, I will correct that. I'm sorry. Are you saying that I also gave you the number for the moon or a number?
But you
For,
give us a number of Earths. That's why I'm confused.
okay. No, I'm sorry. You're totally right. And I will correct that. And
Okay.
to everybody who's listening, that should be Earth. I don't mean to say moon. That should be Earth the whole way through. That is definitely a typo. Yes.
And
that's also
there's a small one in the first question B. If you look at the B, it's the east to power of something, right? But in the question, you're asking is a cosine expression. Well, this is not cosine, so that's a typo, not big deal. But in the second one, you're asking for the period. Well, this thing doesn't have a period. This thing is a one-way ticket. Is that a trick question or?
No, that's interesting. That's not meant as a trick question. Okay, that's interesting. Let me think about that for a second. I see what you're saying with that. The other thing definitely is a typo. Yes. That's interesting. Okay, that is that's a good point. Okay, yeah, I will say for that one is now officially, and I will put this, I'll put an update in the Google Classroom. The last thing that Yabos just said, wait, which part again is it? Can you tell me which part?
1B.
1D? Okay.
1B,
Okay.
Bravo B, yeah.
1B. Actually, let me look for a second because I'm about to say that is a free points for everybody. Hold on, let me just make sure I'm looking at the right thing.
But it could be.
Yeah, no, it will be. I just have to make sure I say the right one. So hold on a second. Where to go? You're talking about. Yes. Yeah, B. So B2. I'm going to say. Right. Yeah, I see. That's a very good point. But I'm going to say how can I put this? Anybody who's listening right now, assuming especially you show all work for part one. So we're talking about to everybody. And again, I'll try to say this in writing in Google Classroom so there's no ambiguity. But if we're looking at the exam, the very first page, problem 1, part B, part 2, I'm willing to say anybody who writes anything at all for part 2, if you write anything, if you don't like anything that makes sense, if you don't leave it blank, you get full points. Like no one will lose points on number 2 because yes, there's a problem with the question. I see, and I don't want to spend too long time, but he's right. There's a weirdness of that question that makes it sort of makes it accidentally a trick question, which I don't mean. So I'm saying everybody gets the points for 2 if you write anything at all. Like for example, you can write why you think it's an unfair question, or you can just write what you think you're supposed to write for what. But anybody who writes anything for 2 will get the full points. That is a promise I'm saying right now, because that is a weird question by accident. Now the other 2 typos are typos, and I will correct them and just reissue the thing. But I don't want to confuse, like, I don't want to like mark it all up and confuse everybody too much. But yeah, the other typo was on. Sorry, actually, tell me again where the other typo was, or the typo was on part.
The moon and Earth thing.
Oh yeah, the moon Earth thing. Right. Okay. Yeah, it's definitely, and this is a good thing too. Yeah, I will change. Oh, I see. Yeah, I'm sorry. Yes, that's totally. I don't know. It says moon. I will change that to Earth and reissue, but that's a mistake. And I'm glad. And again, this is sort of why I am glad that we have this class in the middle. Like, I do make mistakes, and I'm not doing them on purpose to trick you, but I don't want problems for you. So I'm glad these are coming up now. I will say anybody finds anything more while they're doing it or something. Again, it is true when in doubt, just the more you tell me, the more I see what you understand. Like, just note, all of you, say we didn't have this class today, right? And we didn't have this opportunity. But say that each one of you who gave me a question in the private chat, like, sort of put that into your exam. Like, if Yabo, these observations that he's raising in class, if he put them in his exam, he's like, I don't even, like, this question doesn't make sense. I think this might be a mistake. I have to take that seriously when I read in the exam as well. And the more answers there are in exam, but more comments like that, of course, the more convincing it is that that person is truly thinking through the exam. Like, you just can't even make these observations if you just literally go online looking for answers, right? So, and I'm not just talking about Yabo, I'm talking about anybody and everybody who put questions in the private chat today. Like, the existence of your question itself already reflects some sort of actual original thought that you're putting into this exam, and it comes across to all of you. I mean, it really does. Like, I really can, you can tell the difference between someone who writes down something that they understand versus someone who writes down something they don't understand. Like, I mean, you could see this in forensics classes too. Like, even the handwriting shakes in a strange way. Like, but again, it's important to know, I'm not asking anybody to have always understood. I'm asking us to get to the level of understanding. So what I'm really saying, all of you, any of you, say you catch another thing that doesn't make sense in a question, even after this whole class. What I hope this gives you permission to do is do your best to answer. Like, say, like the moon thing is a good example. Be like, the moon? Why is he suddenly bringing up the moon? Well, I'm going to assume that this question makes more sense if we're still talking about the Earth. So you write that. Like, I'm going to assume we're still talking about the Earth. If it were the moon, I'd have to put in a different radius now, which I don't have. Or something. Like, just talk to me. That is where it's your original exam. You just talk to me. And here's a hook too, especially for those of you who had me last semester or anything. I've had some very rough semesters in my life for sure. Last was one of them. But this one, I'm kind of trying to send a message here. I hope you all see that every single thing you've done until this point that you've turned in, all of you, whatever amount it is, anything you've done, I think has come back at this point, which means I have a very fresh plate and excited to see all your exams. Like, I will be looking, I mean, not to be weird, but believe me, I've got the room and the space and the excitement to look at them. Last semester was a little bit unfortunate how certain things went, but so just trust that I will listen to you in your exam and you'll tell me what you do or don't feel comfortable with. And the more extensively you do, the better. And the last thing then about that, I'm glad that some of, there's only been 3 homeworks, but many of you have done all 3. And the best thing about doing those homeworks is that if you got them back, you kind of are in the habit of seeing what kind of thing I'm looking for and what I'm not. Some things I'm super picky about and some things I'm not. And that's a little bit hard to predict. A little bit of it is physics style and a little bit is my style. You're trying to give me your style on the exam. We'll know if there's an honest communication or if there's not. And where I do want to agree that I'm hoping that this is all cool and stuff is if your exam is basically an honest communication of some honest, authentic physics that is now in your brain, whether you got it directly from me or from the web or whatever, cool. Like, if we have an honest communication about it, then your grade is pretty honestly probably going to be good to everybody. Because again, you're seeing that some of this stuff is hard enough to understand, even if you're like looking at it, it's hard enough to understand. But all right, I'm talking. Oh, so wait. Yeah, wait. So hold on. So no, I'm also admitting here. I'm saying I did have problems last semester, and I apologize. And that's true. But I think, yeah, I don't think there'll be problems this semester. And plus, also, by the way, everybody, also Professor Liu is in principle involved in all this, and she's all ready to grade a bunch of exams. I don't know if she has as much time as she thinks she does, or as much. But no, these exams will get graded. Fear not. And again, I apologize if there's any doubt about that. It's because last semester was bad. But that was bad, and I don't think that will repeat this semester. But now there's another question in the chat about period 1B. Oh yeah, the thing we just said. No, very fair question in the chat. Somebody wrote, so wait, for 1B, the thing we all just said in the very beginning of the exam, someone wrote in the chat, so wait, is there no period for 1B because it was not a solution? So do I just write that? Okay, that's not exactly what I'm saying. That's interesting. If we look at 1B, I'm not, you're supposed to say whether it is or is not a harmonic oscillator. Right here, right now, I'm not asserting, like in B1, your answer is yes or no. Right here, right now, I am not telling the class whether it's yes or no. Like maybe that's been implied, maybe some of you are telling each other, that's fine. But I'm not saying that. That's up to you to say whether it's yes or no in number one. Now I am agreeing with an objection that was raised that like number two says, if no, why no? Okay, so if you say no to question one, then there's like no problem. You can just explain why no. Now then it says if yes, if it is a harmonic oscillator, then tell us its period. Now, what one person in the class is saying is that even if this is a harmonic oscillator, that the way that that equation looks, he doesn't see how you could say that there's a period in that equation because it's like not a cosine or a sine. It's not something that looks like it has a period. And I'm not disagreeing with him or her, well, him. Like he's saying, whatever you're talking about harmonic oscillators, I don't see a period even remotely in that math. So if the answer to question two is that this is a harmonic oscillator, I don't know how to tell its period. And that's like a fair enough, like that makes the whole thing seem like a tricky enough question that I'm just saying I will accept anything you say for number two. But still, I would like everybody to give me an answer for number one, whether it is or is not satisfying harmonic oscillation. I think that's the legitimate question that you're all being asked. And then if you say that it's not, then there's no problem in question two. It's only if you say that there is that there's a problem. But all right, now it's okay. That's okay. So I think that's it. 126. I think we've got like 4 minutes. I don't know. My goal today, and this never, it's always tricky to meet in the middle of exams. The reason we're meeting is I'm hoping that by meeting in the middle of this exam, that somehow from most of you, well, I'll get less stressed. Like hopefully, even if this was long, hopefully some things we said today make you think that you're not so crazy about the exam. Like if you did have trouble with something or you thought there was an error somewhere or something seemed weird, hopefully some of this clarified so that you have less stress. Hopefully this means you all can turn in exams that are that much better. Like the idea is you're going to turn these in at 10:50 at Wednesday morning. And again, like I'm very loose about certain things and have fallen behind about certain things some semesters. But this semester, I think it's fair to say that, some things are tight. And I think exams have to be tight. Like you want to turn this thing in before 10:50 and then you want to show up to class. And that is like part of your, it will be noticed and suspicious anybody who's not in class on Wednesday. And I definitely can tell you all, what you don't want to be is the person that shows up in the last 10 minutes of class and then submits your exam or something, because that's blatantly unfair to everybody else in the room. Like, I don't need to tell you that, but just note, and that's also totally recorded, right? Like it's the one thing with Google Classroom. If you do turn in your exam 45 minutes late, especially because you didn't sit through class, everybody else somehow found a way to cut it off and show up to class. So you don't want to be that person. Like there will be consequences of that. I mean, obviously, if someone has an issue and they write me and they're in the hospital, blah, blah. But like, if something is going on with this exam, I guess the best thing I could say is if anything is going on with this exam that will threaten your timing of it, that is something I'm serious about because it is an exam and it already is such loose conditions that I have to defend to other people. I mean, it's such an unusual way to do exams that I can conscience it as long as they come in on time and then everybody comes to class. So please do. And if you anticipate any issue, just communicate to me in advance. Especially through Google Classroom, where even there, I'm getting all the notifications and stuff. Like it hasn't been the issue that it was last semester, I'm pleased to say. So if you anticipate a problem or text me or whatever, but let me know, even if I don't respond right away, then it's on record that you let me know. For this, we are kind of interested in being very strict. So don't turn in the exam late unless you give me a heads up. And even if I don't acknowledge the heads up, you will have given me one, and that will make things softer on the other side. Like, I hope that it makes sense. But then also, but yeah, I mean, turn in as much, write as much as you can, make it, use as many colors as you can, like whatever you've done on homework that I seem excited about, even on your little game turn things, like just clarity, colors, skip lines, make diagrams, just like think of the whole thing as you're trying to demonstrate that things make sense in the universe and to you. You're trying to show that it all makes sense. I know it's right. You know it's right. It's fine, except when it's wrong because there are mistakes. But you're not trying to show that it's right. You're trying to show that it makes sense to you. And wherever you think it doesn't make sense, the more honestly you can say that, that's super helpful too. Because maybe you're just disagreeing, whatever. That's cool. Or okay, I think that's so. I think. Wait, I'm just looking. I think that's what we got today. Oh, chat. Wait, sorry, I just saw the chat. I think. Did I answer any? Did I answer any? Okay, cool, fine. Yeah, that's funny. Okay, I'm just yay and the private chat things, and I thank you for the offer for help. Some, but I don't. That's cool. Okay, I think I'm good. If you guys are good, so goodbye. I'll just wait for a second to see if there's any last questions or anything. But thank you. Have a good afternoon. Great. Thank
Have a
you.
nice afternoon.
Have a nice afternoon. Oh, good. Oh, good. Thank you. You too. Thank you. Okay, cool. Thank you.
Bye.
Cool. Thank you.
Bye,
I have a
Professor.
lot of
Thank
fun
you.
doing this exam.
Say bye. Thank you. Sorry, what'd you say? Say again.
I
Young?
said I have a lot of fun doing this exam.
Oh,
Not
good.
so current. I really have a lot of fun doing this exam.
Oh, that's a very nice thing to say, especially because of what that's a very nice thing to say, especially because you are raising very good critiques. I'm glad to hear that's not driving you crazy. That's good.
Well, it is. That's why it's fun. I'm not being sarcastic, but I like that. Like you're asking question like way beyond our stuff, and we have to think about it
Well,
and
cool. I
question your
know.
way.
Well, we should work together like this more often. When this whole thing is over, you should stick around. Believe me, I could use you on my side in more ways than one. I mean, I appreciate your offer to help the other thing. I think it'll be.
So how can I find you?
Oh, well, first of all, do you have my here? One second. Hold on. That's that's the easiest thing. As long as you tell me who you are. I mean, I know who you are. I mean, as long, the first time, if you tell me, that's how. But
Okay,
you?
thank you.
Oh, thank you. All right, cool. Well, all right. So we'll keep talking. But good
Yeah,
stuff. Thank you
yeah,
very much.
yeah. Have a good afternoon.
All right, cool. Okay. All right.